question is, what is the address of A43? That means 4th row, 3rd column. As it is a row major order, as the array is sorted in row major order, so it is first calculated in this way. So this row will be calculated first, then after this, then this, and then it is goes to this. So as it is a row major, as it is sorted in row major order, so we have to find how many columns are there. So we have 4 columns there. So to calculate up to this, we have to calculate how many columns are calculated in first iteration. So for each iteration it will be calculated 4, that means up to 4 minus 1. So this is 1 1, so 4 minus 1. So 4 into 4 minus 1, as it is 4 columns. So for this row we have to first consider in these rows. So we have to first multiply this number of columns with the number of rows. So number of columns into required number of rows, 4 minus 1. So 4 into 4 minus 1. Then how many columns left? So this will be 3, as it is starts from this will be 3 minus 1. So this is 3 minus 1. So this is our equation. Now 100 plus 2 into 4 minus 4 into 3 plus 3 minus 1 equal to 2. Now 100 plus 2 into 3 4s are 12 plus 2, that means 14. 14 into 2, that is 28. So the address is 128, and we can see in this array that 100, 102, 104, 106, 108, 10, 12, 14, 16, 18, 20, 22, 24, 26 and 28. So this is the address of this location. So in case of the array sorted in row major order, we have to calculate the address of this location by using this formula. Now when it is the array is ordered sorted in column major order, so here the same problem, base address is 100 and each cell contains 2 bytes, and it is a 5 into 4, that means 5 rows 4 columns. So in case of column major order, it will first consider this way. So this way will first considered, then this way, and then this way. So first we have to calculate how many rows are there. So here we have 5 rows. So number of columns is 3 minus 1. That means this 3 minus this base address 3, base address 1. So 3 minus 1 columns will be calculated with 5 rows. So 5 into 3 minus 1, and then 1, 2, 3, 4. That means this address minus this address, as this is started from this, so this will be 4 minus 1. So 3 plus 5 into 2, that means 3 plus 10, that means 13 into 2, 26. So the address will be 126. As we can see that in this way, if we calculate the address of this manually, then we can have 126 address here. So this is our final address of this 43 in when the array is sorted in column major order. Now in other way, if the array is written as a equal to 4 dot dot 7, that means it will starts at 4 and ends with 7, and column will start as minus 1 and ends with 3, and it is mentioned that base address is 100 and each cell requires 2 bytes. Now we have to calculate the row equal to 7 minus 4 plus 1, that is 4, and column equal to 3 minus minus 1 plus 1, that is 5. So number of row equal to 4 and number of column equal to 5. Now we have to calculate the address of 6th row, 2nd column. So this is a row major column, so we have to first consider the number of columns here. So this is the number of columns. So number of columns into how many rows it passed up to this. So 6 minus 4, and then the number of columns left, that is 2 minus 1 minus minus 1. So this is the equation. So 100 plus 2 into 5 into 2 plus 3, 100 plus 2 into 13, that means 26. The address will be 126. When this problem is considered in an 2D array sorted in a column measure order, the problem will be same. We have to calculate the row and column in the same way and then find the address of 62. In this case, when it is a column measure, so we have to calculate the address of first column first. So for the first column, so number of columns, it will be 2 minus minus 1. So this will be number of columns. So this will be multiplied by 4, that means number of rows. So to reach the address of this address, it will pass through this number of cells. Then after that, it will require 6 minus 4 up to this row. So 6 minus 4. Now this is the equation. 100 plus 2 into 2 plus 5 into 3. So 2 into 2 plus 15, that means 2 plus 15 equal to 17. 17 into 2, 34. So the address will be 134. So A62, the address of A62 will be 134. I think you all understand the problem of address, calculation of address of in a 2D array in row measure order and also in column measure order. Meet you in the next video. Till then, practice more queries. If you have any queries or need any suggestion, let me know in the comment section. Thank you for watching this video.